Okay, we're going to find the absolute extreme of this problem, okay? And what are absolute extremes? Absolute extremes are absolute maxes and absolute mins. So we are finding like Mount Everest and we're finding Marianas Trench. You guys good with that? And the way to do that in calculus is to set up what we call a candidates test, okay? It's a test where you put all the candidates in there, all the candidates for your absolute max and all your absolute mins, okay? And remember what we talked about last week? We talked about the candidates for the absolute max are always where there's a relative max, or it could be an endpoint. Those are all the candidates for the highest point. And all the candidates for the lowest points are going to be places where you have relative mins, okay, or they could be at endpoints. You guys good with that? So for sure, in the candidates test, we can already put in our endpoints. Does that make sense? Okay. The other things you need to put in are your relative max and mins. Well, it turns out my relative max and mins are everywhere where the derivative is equal to d and e, or where the derivative is equal to 0. And we have a vocabulary word for that. That word is a critical point. Okay. So absolute maxes and mins, what do? You set up a candidates test. What do you put in the candidates test? You put in your endpoints and you put in your critical points, all right? I've already put in my endpoints. Those are like the easiest to put in. The critical points take a little bit more time. So what I do is I set the derivative equal to 0, or I set the derivative equal to d and e. And I find all the x's where either one is true, and I list all those x's in here, okay? If my x's happen outside the endpoints, then I'll ignore them, okay? If they happen inside the endpoints, then I will include them. So what's the derivative of 4x3/4 minus 3x? Do you see a minus sign in between? So really, I'm doing two separate problems. I thought I just got to do one, but oh boy, I get to do two. Okay, so this is going to be y prime is equal to 4 times 3/4. You guys okay if I just say 3? 4 times 3/4 is 3. X, take the power down by 1. If I'm at 3/4 on the number line and I move down by 1, where am I now? Negative 1/4. Okay, what's the derivative of negative 3x? Negative 3. Set that equal to 0 and set that equal to d and e. All the answers I get from here and all the answers I get from here, they're all called critical points, all right? What you want to do is get a simplified fraction. If you have fractions, you want them to be simplified. So what I'm going to do is I'm going to change this to 3 over x to the 1/4. Simplified fractions means no negative exponents, okay? When you have to solve for things, that's why you want simplified fractions. That's why sometimes instructors will count things wrong if you have a negative exponent in the end. Not that the value is wrong, it's just that it's not ready to be manipulated in any way, okay? So you want to get rid of your negative exponents, okay? On the left side, if you have a fraction, you usually try to cross multiply if you can. Usually that's the strategy on the left side. On the right side, if you have a fraction, the strategy is to set the denominator equal to 0, okay? Because that's when this is going to be undefined, right? Like what makes this thing undefined? What makes this thing undefined is when your denominator is equal to 0, right? So if this is equal to 0, how do I solve for x here? How do I get rid of the 1/4? I just raise this to the 4th power, right? Because 4 times 1/4 is 1, and I raise this to the 4th power. So this will be x equals 0. Eric, can you see with your eyes closed? So x equals 0, okay? So that's going to be one critical point, okay? On the left side here, remember the strategy is to cross multiply if you can, okay? So this is going to be 3 over x to the 1/4 is equal to 3. Now, bummer, because I wanted one fraction on the left, one fraction on the right, and I don't have a fraction on the right. I can make it a fraction, so that would be 3 over 1. And I have an equal sign in the middle. I'm ready to cross multiply. So this is 3 times x to the 1/4 is equal to 3. I'm going to divide both sides by 3. That's going to give me x to the 1/4 is equal to 1. And then how do I get this x by itself? What would I raise this to? The 4th power. So I raise this to the 4th power, which means I raise that to the 4th power. So I get x is equal to 1. And that's also a critical point. All right, I'm going to go take my critical points and put them into my candidates test. These are all the places where there could be relative maxes and mins. So I'm going to put 0. Oops, there's already a 0, so I don't need to include that. And also I'm going to put 1. If you get a critical point that's on your endpoint, the book says it doesn't count as a critical point anymore. Okay, so just FYI, if they ask you to put in critical points, you wouldn't count it if it already was an endpoint. Okay, it's not that it's not a critical point, but it's because on the endpoint there are no relative maxes and mins. Okay, so you wouldn't count it if it's at the endpoint. All right, so let's go ahead and stick it in our candidates test. All right, first I'm going to plug in 0. So what's f of 0? Now here's a question. Do I plug in 0 into f, or do I plug in 0 into f prime? Into f. Okay, so be very careful, guys. This over here is your f or your y. Okay, and so that's equal to 4x to the 3/4 minus 3x. Don't plug it into f prime, okay, because you're going to get something totally different. All right, sometimes you'll get 0, sometimes you'll get d and e, and sometimes you'll get something totally weird. Okay, so I'm going to do f of 0. And so that's going to be 4 times 0 raised to the 3/4 minus 3 times 0, which is 0. And so do you guys see that that's just 0? Because 0 raised to the 3rd power would be 0. If I quadruple or quartic rooted it, 4th rooted it, that would be 0. So this would just be 0 minus 0, which is 0. Okay, let's plug in 1. Okay, so I'm going to do f of 1. I guess it's really y of 1. So y of 1, 4 times 1 raised to the 3/4 minus 3 times 1. Okay, what's 1 raised to the 3/4? 1. So this would just be 4 minus 3, which is 1. 1 and 1. Okay, let's plug in 2. So y at 2 is equal 4 times 3, times 2 to the 3/4 minus 3 times 2. Am I plugging in 2? Yes. Okay, right here, guys, if I 4th root the 2 and raise it to the 3, what do I get? I actually don't know. Let me just take 2, raise it to the 0.75, and then times 4. Okay, and then subtract 6 from that. I'm getting 0.727. Can I get a check on that from anybody? Okay, so guys, once you fill out your candidates test, okay, these were all the candidates for the largest and smallest value. There are no more candidates, all right? So what's my largest value? Okay, so I'm going to say max equals 1 at x equals 1, okay? What's my minimum value, my smallest value? 0, and where does that happen? X equals 0. That answer almost seemed too easy, but that is my answer. That's my max and that's my min. Okay, any questions on absolute extremas? It's exactly how you do it. All right, let's go ahead and move into the lesson today, and then we'll go backwards and answer homework questions. Today, I want to make sure that you guys know the difference between EVT and IVT, because we're going to add MVT today. All right, so what is EVT? EVT says that if you have a function that's continuous on a closed interval, okay, and if I said it in my own words, I would say if f is continuous on a closed interval. That's all I would say if I said it in my own words, okay? EVT says guaranteed you will have one maximum and one minimum. Like guaranteed you'd have a max and a min. You might have, I mean, you could have more than one maximum, meaning like you could have 2 points where the top, you know, you have 2 Mount Everest. That's allowed, okay? But that y value would be the same, right? Even if you had 2 Mount Everest, that y value would be the same. So then it's really just one maximum. Okay, so f is continuous. Okay, then f always has a maximum, and I'll clarify this, an absolute maximum and an absolute min. Okay, that is what EVT says. You always have an absolute max and an absolute min as long as the function is continuous on a closed interval. And closed interval means dots at the end. Okay, IVT is very similar. Do you guys remember IVT? Because we had to prove it so many times. Okay, IVT says that if f is continuous on the closed interval. Now notice, exactly the same as EVT. Okay, but then it strays from there. Okay, remember we had President Trump in the front of the room? Or was it Justin Bieber? I don't remember. Trump, President Trump in the front of the room. And IVT says that if the function is continuous, you're going to hit every value between this y value and this y value. Okay, guaranteed you'll hit every value in between. So IVT says f attains all values between f of A and f of B. Okay, make sure you understand this is everything about y values, okay? The only x values we talk about here are the interval values, but everything is a y value. Every y value hits every number between this y value and this y value, okay? All right, and then even EVT, we're really just talking about y values. The minimum is a y value, the maximum is a y value. The only time we talk about x values are the interval, okay? All right, so today we're going to talk about MVT. Oh, let's just do one more definition. Can you guys fill in the blank? What goes in this blank? C is a critical number when two things happen. What do you have to do to get critical numbers? You set your derivative equal to what? 0 or, okay, D and E. Guys, you need to be able to fill those blanks in. That's what the definition of a critical point is. Okay, now we're going to go to the GT part of our show today. And what that is I'm going to ask you, you have a little bit of space in your notes to draw a function, okay, that's smooth, that's continuous and differentiable. Okay, so continuous and differentiable. Differentiable means it's a smooth curve. And so go ahead and draw. I don't want to sway you because I don't want to draw anything here that you have to copy because yours should look different from mine. Okay, so draw any curve you want. Okay, it should be a function that's smooth and continuous. Okay, no, sorry. Yeah, continuous and differentiable, which means smooth and continuous. If something's differentiable, it just means, well, if it's not differentiable, right? I'm like you and you're like me, not differentiability. I put not in there so it'll make more sense with this. But anyway, what was not differentiable? Sharp, turn, vertical, tangent, any discontinuities. And what are the discontinuities? Joy, hole. So you can't have any of those. Does that make sense? Because if you have any of those, then you're not differentiable. And I want something differentiable and I want something continuous. Okay, you got your curve? Okay, so curve doesn't have to look like mine. Okay, then I want you to do is, actually, let me make something more like what you guys might have done. Okay, then what I want you to do is pick 2 points, any 2 points you want. And those are going to be your endpoints. Pick 2 points for your endpoints. So label one A and label the other B. Okay, get your tangent line ready. What I want you to do is I want you to draw a secant line. Remember what a secant line is. Okay, a secant line just connects 2 points on a curve. Yours should be straight. So draw a secant line. Okay, now we're just going to go from A to B. So if you're outside of A, don't worry about it. We're only going to go from A to B. And I want you to get your tangent line and set it right at A. So set your tangent line at A. Okay, then I want you to take your tangent line and move it along your curve. And anytime your tangent line is parallel to your secant line, okay, I want you to just draw a dot and label it C. Okay, so go between A and B, take your tangent line, run it along the curve, and anytime your tangent line runs parallel to your secant line, if it helps you, you could put a little dot on your toothpick and line that dot up to your curve. And anytime that tangent line is parallel, you guys know what parallel is, right? The slope is the same. Then go ahead and put a dot and label it C. Okay? And do it every time that you get a tangent line that's parallel to your secant line. And you only have to go from A to B. Okay? I know your tangent line is very helpful. You can't use it on the test, by the way. But you can take it home, share it with your friends and family, maybe pick up a girl or boy that way. I don't know, whatever, if it works. Actually, I think it would work. Okay, it just depends on what type of person you want to pick up. Okay, there's only a certain type of people you might attract if they get excited by your tangent line. Okay, all right. How many of you guys got 3 or more C's? You got 3 or more C's. Okay, so your curve must have been curvy. Okay, how many of you guys got 2 C's? You got 2 C's. How many of you got 1 C? You got 1 C. You got 1 C. Okay, how many got no C's? 0 C's. No, that's great, because that's exactly what MVT says. MVT says that if the function is continuous on the closed interval, and that's exactly what our function was, And if the function is differentiable on the open interval, that just means you don't have to worry about the endpoints being differentiable. Everything's smooth in between. Then you always have at least one point. There's always at least one C. There's at least, this is bad handwriting, there's at least one C. You always have one C or more where the slope of the tangent line is equal to the slope of the secant line. And I think that's written for you right here, okay, MVT. Do you guys see that? And that's exactly what we proved in this class. No one here had 0 C's, right? Or if you did, you were too ashamed to admit it, okay? But you had no C's. It's impossible to have 0 C's. If you drew a function that's continuous on the closed interval and differentiable on the open interval, okay, MVT guarantees there's at least one time, there may be more, there might be 2, some of you guys had 2, some of you guys had 3, okay, but there's at least one time where the derivative, right, isn't that what the slope of the tangent line is? The derivative is equal to the slope of the secant line, okay? So let's see a different problem related to that. We're going to go to, I think we're going to flip to the back of your paper now. We're going to skip Rolle's theorem, by the way. So we're going to go to the back of your paper. And let's do the back of your paper, and then we'll flip back to the front. Okay, so we have this problem, and this is a typical MVT problem. Okay, it's very nice of them to draw you a curve. Sometimes they draw you a curve, sometimes they don't. But this curve is basically just f of x. And here's f of x right here. They just graphed f of x for you. Okay, and they said, first, show MVT visually. What is MVT saying visually? Okay, well, MVT is saying if this function is continuous on the closed interval. So let's go find the 2 dots for this. Here's 1, 2, 3, 4, 5. Here's 5. Okay, so here's my dot for 1, and here's my dot for 5, just like you guys did, except you guys didn't have an x-axis, okay, on your paper. But it's the same thing that you did. This person drew a curve like this, and what we're going to do is we're going to connect the 2 dots, and that's the slope of my secant line, okay? And MVT guarantees that if this black line is continuous on the closed interval and differentiable on the open interval, you are guaranteed to have at least one point where your slope of the tangent line is equal to the slope of the secant line. So go ahead and take your tangent line, run it between 1 and 5, and go find that dot. Go find where that dot is. You guys go try to find it. We're going to try to do it visually. Okay? And wherever that dot is, label it C. Okay? That x value, C, is what we're trying to find. Like, where does it happen? Okay, where does it happen that the slope of the tangent line is going to be parallel to the slope of the secant line? Okay, go find that C. And based on what you guys did on your paper, can you write down a number what you think C might be? And then we're going to calculate it and see if we get the same number. So what do you think C is? Maybe like 2.25. Okay, so we're going to say 2.25. And let's see how close we get. All right, so that was with a visual. That was doing MVT, you know, with a picture. Let's see if we can do MVT algebraically. All right, letter B says, show that the mean value theorem applies. All right, so this is just like IVT. You basically have to say that F is continuous on the closed interval first. So F must be continuous on that closed interval, just like IVT. We did this for IVT, okay? But MVT has an extra thing. You can't just be continuous. You also have to be differentiable. So F is continuous on the closed interval and differentiable. And when you say differentiable, though, it's on the open interval, okay? And this open interval just means this is actually even very nice. Like, you don't even have to think about, do you have a sharp turn, vertical tangent, discontinuity at the endpoints? Don't think about it. You just need to know in between, is everything smooth and continuous, okay? Therefore, it's differentiable. All right, if these 2 conditions apply, do they apply, guys? Am I smooth and continuous right here between 1 and 5? Yes. Then third, f prime of C must equal f of B minus f of A, okay, all over B minus A. This must be true at least 1 point. Might be true at more points, but at least 1 point. So let's go find those points or point, okay? How do we do this? All right. Well, guys, this is f prime of C, but just FYI, I usually do x, okay? I solve for x instead of solving for C, just because I like solving for x. You can put C if you want, just make all your C's make all your x's c's. Okay, just FYI, I use x here instead of c. Okay, I do write the formula as c for some reason, but then when I plug it in as x. Okay, so what's the derivative of f? All right, here my f of x is equal to, I'm going to write it down here, 3 minus 5x to the negative 1. Are you guys good with that rewrite? Because I'm not going to be able to take the derivative unless I rewrite it. Okay, let's go ahead and take the derivative. What's the derivative of 3? 0. What's the derivative of negative 5x to negative 1? 5x. All right, I'm done with the left side. Let's look at the right side. What is my a and what is my b? Where did... Oh, did I not do that right? Oh, yes, I'm sorry. I forgot negative 2. So 5x and negative 2. Thank you. Sorry, I did that wrong. Okay. What is my a and what's my b? A is 1 and b is... Okay, so let's go ahead and plug it in just like that. Everywhere there's a b, I'm going to put 5. And everywhere there's a, I'm going to put 1. Okay? Now, you guys notice that this right here, this really is just average rate of change. Do you remember that? We've tested on average rate of change before. So let's just go to the side of our paper and find average rate of change. What's f of 5? Now, here's the key. Do I plug in the derivative or do I plug in f? F. Plug it into f because it's f of 5, not f prime of 5. So go find f. It's going to be easier to plug in this f than it is this f. So go find f. And just everywhere there's an x, put in 5. And I'll get, oops, 3 minus 1, which is not 4. 3 minus 1, which is 2. Is everybody good with what I just did? Everywhere there's an x, put in 5. Okay. I also need to do f of 1. Okay, so same function here. Everywhere there's an x, I'm going to put in 1. Okay, so I get 3, wait, is that even right? 3 minus 5? Yeah, that's right, is negative 2. Okay, so now I have f of 1 and f of 5. I'm going to plug in on this side. So this is f of 5, which is 2, minus f of 1, which is negative 2. Be careful of these negatives. 5 minus 1 is 4. So what I get is 4 over 4. And here's where students make the biggest mistake. They set this 4 over 4, they say it's equal to 1, they box it in, and they go to the next problem. Okay, what did I just find about this one? Is this the x value where the slope of the secant line is equal to the slope of the tangent line? No, it's just the slope of the secant line. It's just the slope of this. Does that make sense? You actually need to set this thing equal to 5 over x squared. Does that make sense? Our goal is to find x. Our goal is never to find the right side of this equation. Our goal is to find x where this equation is true. And we know it's true at least at one point because of MVT. All right? Okay, so this is our goal, to solve for x. So let me just erase this box to make sure you understand. What a lot of students do is they just find this right side and they think that's the answer. Okay? Our goal wasn't to find the slope. This is the slope. Okay? Our goal was to find the x value where both slopes were 1. Okay? All right. So I'm going to cross multiply if I can. Got to make the right side into a fraction. Okay, so this will give me x squared is equal to 5. Solve for x. So x is equal to plus or minus square root of 5. Okay. Guys, you need to have a number that's inside your interval. Okay, MVT only guarantees the x value in that interval. All right, so the answer is negative square root of 5 and square root of 5. Guys, which one is this one? Square root of 5. So that is my answer. It actually would be negative square root of 5 because if you graph this, it would kind of look like a, there'd be a, right, there's a vertical asymptote at 0. So you actually over here, there is a c actually also at negative square root of 5, but that's not within our interval. Does that make sense? So we're only going to grab the answer that's within our interval. What is negative square root of 5? I mean, square root of 5. Did we get close to 2.25? 2.24. Look how close we were. Wasn't that nice? Okay, so you can do it with a picture, okay, but you can also do it mathematically. All right, how comfortable were you with that? Just jump back to the front of our paper and then we'll jump back to the back, okay? There are times when MVT doesn't apply, okay? When does MVT not apply? Well, when the function is not differentiable on the open interval or when it's not continuous on the closed interval. So let's look at all these functions. And sometimes the answer is MVT doesn't apply and you just stop doing the problem because MVT doesn't apply. So let's look at x cubed. These are parent functions that you need to know, okay? So x cubed looks like this right here, okay? Not to be confused with the cube root of x, okay? The cube root of x looks like, oops, I'm not drawing it very well, but the cube root of x looks something like this, and this is x cubed. Okay, so I'm going to look at x cubed between 0 and 1. So all I'm worried about is this green part of x cubed. You guys good with that? Just between 0 and 1. Okay, question. Just looking at this green part, is the function continuous on this green part? Is the function differentiable on this green part? Yes. No sharp turns, no vertical tangents, no horizontal, no joys, no holes. So I would say MVT applies. And you would proceed to do what you did on the last problem. You would set, the derivative equal to the slope of the tangent line. I'm not actually going to do it, but you would set this equal and solve for x. Everybody good with how you would proceed with this problem? Okay, let's go to the next problem. Guys, you need to know the parent function for absolute value of x. What does the absolute value of x look like? Do you remember? Yeah, it's just a v. Okay, it's just a v. But there's a shift here. Okay, now, is this an up and down shift or is this a horizontal shift? It's horizontal. If it were up and down, it would look like this, just to help you to see the difference, okay? This shift got inside the parentheses, so this is a horizontal shift and this is a vertical shift. Now, with the horizontal shift, am I going to shift left or right by 2? Right. It's opposite of what you think. It's I-hod over, right? So right here, and I'm going to look between 0 and 3. So if this sharp turn was originally at 0, now it's at 2. Is everybody good with that? Okay, so that means between 0 and 3 would be this part of the function. It's like a check mark that's kind of backwards. Everybody good there? Okay, question, does MVT apply on this red part of the function? No. What's the reason? Sharp turn. Okay, so actually you can only tell me this reason or this reason. You can tell me the function's not continuous, or you can tell me the function's not differentiable. Not differentiable. So you would say MVT does not apply, doesn't apply, because the function is not differentiable. And when you say differentiable, you have to say on the open interval, because that's the definition of MVT. Differentiable on the open interval and continuous on the closed interval, brackets. So if you say differentiable, you have to say open interval. Okay, is everybody good so far? Okay, so right here, since it doesn't apply, you would like drop your pencil down and go to the next problem. Well, don't drop it down, pick it up, but go to the next problem. Okay, don't continue with this problem. All right, let's look at the next one. What would a graph of x minus 1 look like, the absolute value of x minus 1? Same thing, but which way am I going to shift it? To the right by 1, okay? So before the sharp turn was at 0, now the sharp turn is at 1. Now let's look at my interval. My interval is between 2 and 5. So if I shaded in 2 to 5, do you see I would be right there in this green portion? Okay, does MVT apply here? Yes, okay, so MVT would apply. You'd say, you'd say continuous on the closed interval, differentiable on the open interval, and then you would proceed with MVT. Okay, you would say, the derivative, oh, well, we're not going to take the derivative of this. Actually, some schools do, but we're not going to, is equal to the slope of a secant line. Okay, we're going to move down. All right, let's look at 1 over x minus 1. Okay, guys, the parent function here is 1 over x. Do you remember what 1 over x looks like? Yes, it's the two things. So 1 over here and 1 over here. It actually has a vertical tangent line at 0 and a horizontal tangent line at 0. Here's the thing. That's 1 over x, okay? But what we want is 1 over x minus 1. So what's the shift going to be? 1 to the right. Very good. So I'm going to pull this to the right. I know you guys are jealous because you can't do this on your paper, okay? But yeah, be jealous of me. Okay, so do you see my new picture here? Okay, now I'm looking at this picture between -1 and 3. So between -1 and 3, does MVT apply? No. What's the reason? The function is not continuous on the open interval. Okay, another thing you could say, that's one answer. You could also say the function is not what? Differentiable. But if you say differentiable, make sure you say on the open interval, okay? And then you would say MVT doesn't apply. And again, you only need one or the other of these check marks. You don't need both. Okay. If you do both, then that's great. Just make sure you say it correctly. All right. And then since MVT doesn't apply, we're done with that problem. All right. Let's look at this one right here. This one's a tricky one. Do you know how to graph x to the 1/3? It's a cube root function. How do you graph it? Don't make it a cube function. Does that make sense? It looks totally different from a cube function. Okay, so that's a cube root function. Something special about a cube root function is right here. If you took your tangent line and ran it along this curve, guess what will happen right when you get here at x equals 0? You're going to have a vertical tangent line. That's something special about the cube root of x. I didn't draw it very obvious that you have a vertical tangent line there, but if you graphed it on your calculator, you would see it. Unfortunately, you won't have a calculator on this test, okay? So you're going to see it because you've memorized the cube root function, all right? So guys, if I have a vertical tangent line right there, let me just ask you, am I differentiable here? No. Am I continuous here? Yes, I am continuous, but I'm not differentiable. So you would say MVT doesn't apply, but you can't use continuity as a reason because it is continuous. The function is continuous. You just have to say because the function is not differentiable on, and make sure you say the open interval. Okay, are you guys comfortable with these? So I just graded BC. BC just had their test on MVT. And I want to say several people missed this question. Okay, so make sure you understand. And it's not even this. Like I combined it with some other ones too. They missed that one too. Okay, so just make sure you understand the difference between like all of these and when MVT applies and when it doesn't. All right, flip to the back. I'm going to do this problem with you guys, this example. After this example, you can do every problem on your homework, all right? The two remaining problems are really just fun problems, all right? But your homework is enough, has enough stuff on it that we're really just covering this front page and this back page of your notes, okay? All right, let's look at this problem here. I'm given this function, x cubed minus x squared minus 2x. It's on the interval from -1 to 1. And the first question is, does MVT apply? Okay, so first, I have to fit two conditions for MVT to apply. First, the function must be continuous on the closed interval. Is it? Let me just point out, this is a polynomial. Do you guys know what polynomials are? They're just like when you have x and then raised to like some whole numbers, x3 minus x squared. The coefficients can be fractions, that's fine, but your powers cannot be fractions, okay? And if you have anything that's that simple, like it's x raised to a whole number, x raised to a whole number, you add them together, that is called a polynomial. And polynomials are always continuous, always continuous for all reals, from -infinity to infinity, okay? And the other thing nice about polynomials is that they're also differentiable. They're always smooth, okay? They're always smooth over all reals too, okay? So whenever you get a polynomial, you can always say the function's continuous on the closed interval, and it's always differentiable on the open interval. You're always allowed to say that for a polynomial, okay? So that's nice, okay? Since these things are true, can I use MVT? Yes, so I'm going to go ahead and start with MVT. And MVT just says the derivative is equal to the slope of the tangent line. I'm sorry, the slope of the secant line. So the slope of the tangent line is equal to the slope of the secant line, all right? So what's my derivative here? 3x squared minus 2x minus 2, right? What's my b and what's my a? Okay, so this is going to be f of 1 minus f of -1 over b minus a. Now be careful of those negatives. Okay, f of 1 is going to be equal to, okay, I'm going to take this to the side of my paper. F of 1 is going to be equal to what? I'm going to go to find my f. It's not f prime. You guys good with that? It's f. Go find my f, and everywhere there's an x, put in 1. Okay, that's how you find f of 1. So that'll be 1 minus 1 minus 2. So I think I get -2. You could check me on that. Then I'm going to do f of -1. Okay, so again, I'm going to go up to my function, and everywhere there's an x, I'm going to put in -1. So now there's -1s in here. Okay, now it's a big mess, but I have -1 minus 1 plus 2. So is that 0? Okay, so I got 0. All right, now I'm going to plug in into my formula here. So this is equal to f of 1, which is -2, minus, let me do it in a different color, minus what? Minus 0 over 1 minus -1, which is 2. And that gives me -1, right? -2 divided by 2 is -1. Did I do that right? Someone check me on that. Thank you. Okay, and here's the number one thing students do wrong. They box it in and they go to the next problem. Okay, is -1 my answer? No, -1 was just the right side of this problem. Do you guys see that? What you need to do is set the left side equal to the right side, okay? Then solve for x, because I want to know the c value. Of course, mine turned to an x, but the c value where the slope of the tangent line is equal to the slope of the secant line. This does tell me something. It tells me what the slope of the tangent line is, or it tells me what the slope of the secant line is, because remember, they're the same, okay? But it doesn't tell me what x is. So what you have to do is move everything to the right side, or I'm sorry, to the left side, okay? Is this going to give me an answer? It does? Okay, so let me just see it here. Yeah, it will. Okay. Then you want to factor the left side. And if I have something times something equal to 0, then what I do is I set one of these, well, one of these something is going to be equal to 0. So I set each of them equal to 0, solve for x. Okay, so if I did this right, I have x is equal to -1/3 or x is equal to 1. Okay, then I go look at my interval, because remember, this has to be in the interval, but it's a little bit tricky. Is my interval -1 to 1? Okay, it's got to be in there, but it can't be at the endpoints, because MVT doesn't guarantee anything at the endpoints. It only guarantees in between that you'll have a value, okay? And so do you see I'm going to ignore x equals 1 because that's actually at my endpoint. So my answer will be x equals -1/3. Yeah. Mm-hmm. Well, it's 3x times -1, so I have -3x. Yeah, so that gave me the -2x. Does that make sense? Yes, you're right. I mean, you're right about that if it hadn't been a 3 here. Okay. Does everybody see why the answer is -1/3 and not 1? Okay. It's not to say that at 1, the slope of the tangent line is not equal to the slope of the secant line. It actually is. It's just the question always is, what does MVT guarantee? And MVT never guarantees anything at the endpoints. Okay. All right. So you guys are equipped and dangerous for your homework. So you may start that online. Your homework's also on MML. But what I want to do now is actually answer homework questions from Extrema last night. So can you guys pull out your homework from last night? Let me do as many problems as we can together. Okay. Yes, Maddie? Yes. So it's number 6, guys. Can you tell me what it is?
It is cubed over 3 plus 14x squared minus 16.
Okay. All right. So guys, we're looking for the absolute smallest number and the absolute largest numbers. Okay. Those always happen at 2 places, at endpoints and at critical points. So the easiest thing to do is actually stick my endpoints into a candidate's test. To find my critical points, what I have to do is take the derivative, set it equal to 0, and take the derivative and set it equal to d and e. All the x values that I get from either one of these setups will go into my candidate's test as long as it's within -5 and 1. Okay, so let me take the derivative of this. So this is going to be 8/3 times 3. So that's going to be 8x squared plus 28x minus 16 is equal to 0. And then on this side, I'll get 8x squared plus 28x minus 16 is equal to d and e. Whenever you have a polynomial, okay, x is good for all reals. So there's no critical points that are going to be generated. No x values would ever cause this thing to be non-existent. Does that make sense? Undefined. Okay. Only when you have a denominator, and no denominators are in polynomials. Well, no denominators with the x's in it, okay? All right, over here, I'm going to have to factor to figure out what x is. So I'm going to pull out a 4, right? I think the 8 won't work. So if I pull out a 4, I'll get 2x squared plus 7x minus 4 is equal to 0. That'll be 4 times 2x minus, this is a 4, is it 1? And then x minus, maybe x plus, you guys are going faster than me. Okay, so yeah, I think that's going to give us this quadratic, okay? And again, guys, those of you guys who are having trouble factoring, and I have trouble factoring sometimes too, but usually I figure it out. But those of you guys who have a lot of trouble factoring, go to Khan Academy, spend 10 minutes, and it'll be totally worth your while, okay, to make sure you understand factoring. If something times something times something equals 0, what does that mean about one of these somethings? One of them is 0. So either 4 is equal to 0, oh, that's silly, 4 isn't equal to 0. 2x minus 1 is equal to 0, or x plus 4 is equal to 0. This gives me 2x is equal to 1, or x is equal to 1/2. And this gives me x is equal to -4. Okay? Now, you would put them in the candidates test only if it's between -5 and 1. Okay? So these numbers, I think, are indeed between -5 and 1, so they'll go into your candidates test. All right. What's f of x? Well, do I plug this -5 into f, or do I plug it into f prime? That's the first question, into f. So go into f, plug in -5, so that'll be 8/3 times -125 plus 14 times 25 minus 16 times -5, and figure out what that is. Does that make sense? Do you guys need me to go on from here, or should I? You do need, okay. Then plug in -4. So -4 would be 8/3 times -64 plus 14 times 16 minus 16 times -4. Okay, I'm going to have to get my calculator out. So, and then plug in 1/2 and plug in 1. If I plug in 1/2, I'll have 8/3 times, okay, I'm just going to go get my calculator out at this point. This is kind of interesting, though, because if you wanted to, and some of you guys know how to do this, you can go into your calculator. Let me find my cool calculator. Oops. You could go into your calculator and set up the table, right? And you can make your table just like your, here, let me get my thing out first. Okay, if I put in here my function, so that's 8/3 x cubed. I'm going on memory from this. I actually don't even know the function. Here it is. Plus 14 x squared minus 16x. If that is my y1, I could go to second table set, right? Go to ask. Go to ask right here, hit enter. And then hit second table. And it's my candidates test. Does that make sense? I can actually just put in the numbers for my candidates here. -5, -4, 1/2, and 1. Hopefully I did that right. Yeah, okay, so those are my answers right there. And so I can put those values here. So I'm going to erase all of this because I was going to do it by hand. But you guys know I'm not impressing anybody, so I'm going to go ahead and put my numbers in here. So I have 96.667. Guys, I want you to go at least 3 decimal places, 117.33, -4.167, and 0.667. You can round or you can truncate, okay? I'm going to pick my largest value. What's my largest value? Okay, so I'm going to say max is equal to 117.3. I should go 3 decimal places. Guys, if you don't know how to go 3 decimal places, what you do, see how I only have 2 decimal places right here? Go put your cursor. Go put your cursor on there. Do you see that? And then your number comes down here. Did you guys know that? And your number shows up here. So you can get 3 decimal places here. That's 3, 3, 3. So that's 3, 3 at x equals what? -4. So that's my max. Okay. What is my min? Go find my smallest number, -4.167. And where does that occur? X equals 1/2. All right. And that's my answer in red right there. Okay, that was fun. We're pumped up. Let's do another one. Number 7. Can you give me the problem?
X equals 4 cosine squared x
Okay.
on 0 pi.
Sure. Okay, so you're going to start your candidates test, and you know 0 and pi are on your candidates test. Okay, we're trying to find the absolute max, the absolute min, so we're going to put all the candidates in here, and we're going to grab the largest and the smallest. Okay, we also need to get our critical points. All right, so what are our critical points here? Well, we're going to have to set the derivative equal to 0, and we're going to have to set the derivative equal to d/e. What is the derivative here? Now, you tell me what you want to do. You can either do product rule if you rewrite it like this. Okay, this would be a product rule. Or if you rewrite the problem like this, no matter what, you have to rewrite the problem. Okay, and you can do a chain rule. Which would you rather do? Okay, chain rule. So that means the derivative is equal to 4 times 2, which is 8. Leave the inside alone. Guys, when I say to leave the inside alone, it really means leave it alone, okay? Take the power down by 1, so this is going to be 1, okay? Leave the inside alone. If it's cosine x, leave it as cosine x, okay? Then you multiply by the derivative of cosine x. What's the derivative of cosine x? Negative sine x. All right, so I set this equal to 0 and d/e. So this will be 8 here, and I've got a negative 1 here. Everything's being multiplied together. So it's negative 8 cosine x sine x is equal to 0, and negative 8 cosine x sine x is equal to d/e. Trying to find all the x's where either one of these are true, and that'll generate all the critical points for me. Okay? All right, guys, do you see I've got something times something times something equals 0? What does that mean about at least one of these somethings? One of these is equal to 0. So either negative 8 is equal to 0. Oh, that's silly. Cosine x is equal to 0, or sine x is equal to 0. Okay? If cosine x is equal to 0, think about your unit circle. What is x going to be equal to? I'm not trying to find cosine x. I'm trying to find x. So let me pull this down a little bit. If cosine x is equal to 0, what angle does that happen at? Pi over 2 and 3 pi over 2, right? And then what about sine x? What happens, where does sine x equal to 0? Think about the unit circle here and here. So that would be 0, pi, and 2 pi, okay? Let's go ahead and look at the d/e before we go into the candidates test. Okay, so these are all critical points. These are all critical points, okay? I'm going to see if I can get some more critical points up here. Guys, whenever you set cosine x and sine x equal to d/e, cosine x and sine x, think about what they look like. They kind of look like polynomials. Do you ever think of, I mean, they go on forever, negative infinity to infinity, and they're really smooth. Okay, they're continuous and differentiable. So it turns out these x's are always all reals. Okay, unless you have a fraction, okay, you'd set the denominator equal to 0, but otherwise it acts like a polynomial. Okay, so no critical points were generated by setting this equal to d/e, because x's can be any number you put in there. It'll always be good from negative infinity to infinity. So now I'm going to take these critical points and stick them between 0 and pi. But do you see this is outside 0 and pi? And so is this one, right? So you disregard numbers that are outside of your endpoints. So it ends up I have pi over 2, and pi and 0, they're already on the candidates test, right? So you wouldn't put it twice. Like, that's silly. Okay, so this is what I have in my candidates test. If your book asks you, are 0 and pi critical points? Okay, I'm just letting you know. Don't say that they're critical points. Even though they are critical points, they don't count because they're at the endpoints. And so no relative mins or maxes would be generated from them. Okay, so if your book asks you if they're critical points, if they're at the endpoints, don't say that they're critical points. Just letting you know. I don't think anybody will ever try to trick you on that. But the book is kind of like picky about it. Okay, all right, let's put in 0. If I put in 0, okay, well, where am I plugging this into, first of all? F of x or f prime of x? F of x. Be very careful about that. That's a big mistake students make. There's lots of mistakes you can make, but you got this far, you don't want to make a silly mistake and then get your candidates test wrong. First, I'm going to plug in 0. So that means 4 times cosine of 0 times cosine of 0. Okay? Did I do my f of x right? Yes. Okay, what's the cosine of 0? What's the cosine of 0? Any idea? Like, what's the, at 0, guys, at 0 degrees, what is my cosine value here? 1. So this will be 1, this will be 1, so I get 4 times 1 times 1. Okay, let's do f of pi over 2. Okay, 4 times cosine of pi over 2 times cosine of pi over 2. Okay, what's the cosine of pi over 2? Think about your unit circle. 0. So that's 4 times 0, which is 0. All right, let's do f of pi. Okay, that's 4 times cosine of pi times cosine of pi. What's the cosine value? Okay, here's pi over here, so be careful. What's the cosine value at pi? -1. So that's 4 times -1 times -1, which is just 4. Okay, so what's my highest value? 4. So you're going to say maximum equals 4 at x equals, actually you have two answers, right? At x equals 0 and at x equals pi. What's your minimum? 0. Where does that occur at? At x equals pi over 2, and that is your answer. Now I got to say, you guys knew how to do this, right? Just admit it. You're prejudiced against Greeks. Okay, you're like intimidated by the problem, but you could do this. So we got to get over that, guys. Okay, let's look at another problem. Do you guys need help with 8? Okay, what's the problem? X squared plus 1, okay. On -2, 2? Okay. All right, so let's look at this problem. Again, we want the highest and lowest numbers, so we're going to set up a candidates test. -2 and 2, okay? Those are my endpoints. The highest and lowest values always happen either at the endpoints or the relative max and mins. How do I find those relative max and mins? First, I set the derivative equal to 0. Then I set the derivative equal to d and e. This is going to catch all of my sharp turns, okay? And this one's going to catch all of my maxes and mins, okay? And whatever number is the highest, that's going to be my max or min. All right, so let's take the derivative of this. Okay, this is going to be quotient rule. So the derivative of the first times the second minus, what's the derivative of x squared plus 1? 2x times the first, okay? That's your numerator. Put it over the denominator, and don't forget to square it, okay? It's very intimidating, but here's the thing. Remember, you're just setting it equal to 0. So when you set this equal to 0, if you have one fraction on the left and one fraction on the right, guess what you get to do? Cross multiply. And when you cross multiply, the whole bottom wipes out because it gets multiplied by 0, right? So what you get is 7 times x squared plus 1 minus, this is basically 14x squared, right? 2x times 7x is equal to 0. You're basically just getting the numerator set equal to 0. And then you solve for x here. I'm going to distribute the 7. So that's 7x squared plus 7 minus 14x squared is equal to 0. So I get negative 7x squared plus 7 is equal to 0. I could factor it, but I could also do cross multiplying. I enjoy cross multiplying more than factoring. So I'm going to cross multiply, but you could actually factor if you wanted to. So this will give me x squared is equal to 1. So x is equal to plus or minus 1. Okay, and those are my CPs. What am I doing? I'm not solving for x. Like, my goal isn't to solve for x, but my goal is to get the largest and smallest value. And to do that, I need to collect as many CPs as I can. Okay, so it's kind of like when you're playing Settlers of Catan, right? You want to collect like as many of those black things as you can, those mineral things, the coal or whatever it is. I don't know what it is. Okay, but we're just collecting as many as we can. All right, let's collect some more critical points. All right, over here on the D and E side, okay, what we do is we set the derivative, which we already know the derivative right here. So I'll rewrite it. That derivative, okay, we want this to be D and E. But remember what I told you, when you want something to be D and E, it's a fraction, really what are you setting equal to 0? The denominator, okay? If you want this thing to be undefined, okay, the way you make this thing undefined is you set the denominator equal to 0. And basically, remember what we talked about, D and E is really 1 over 0? If you call this 1 over 0 and you cross multiply, you'd basically be setting the denominator equal to 0. You could call this 212 over 0 too, okay? But while that would show your school spirit, you wouldn't have a lot of time to show it because you'd be busy doing this problem, right? So it's easier just to set this equal to 1 over 0, cross multiply, or just set the denominator equal to 0, which is what we're doing. All right, how do I like isolate the x squared plus 1? Yeah, take the square root of both sides. So over here, you'll get x squared plus 1 is equal to 0. I guess technically you get plus or minus x squared plus 1 is equal to 0. Technically, I don't know, that seems kind of hard. It doesn't really matter because if you divide by -1, it doesn't matter. It'll still be equal to 0. Okay, so this plus or minus is not, you can do it, you'll see it's still the same. So what you'll get here is x squared is equal to -1. Okay, and so what do you get here? Yeah, an imaginary number. So no CPs here. No real CPs are generated. You really only want real numbers. Okay, so what we have is -1 and 1, and we're going to come up here and we're going to make sure that they are between the inputs, the endpoints, sorry, and they are. They're between the endpoints. And so at this point, we're just going to plug in for our f values. Okay, so let me erase some things here. First, I need f at -2. Okay, f at -2 will be 7 times -2 over, this is -2, this will be 5, right? -2 squared plus 1, that's -14 over 5, so that's what this is right here. Okay, then I'm going to plug in 1, -1, so -1 would be -7 over 1 plus 1, which gives me -7 over 2, which is no, it is -3.5, okay? If I plug in f of 1, I'll get 7 over 2, which is 3.5. And finally, if I plug in 2, f of 2, I'll get, is that 7? I'll get 7 times 2, which is 14, over 5. Okay, whatever that is, that's 14 over 5. A little less than 3, right? Whatever that is, that's less than 3. This is less than no. Well, anyway, it's less than 3. So which is my smallest number? -3.5. So I'm going to say the minimum equals -3.5 at x equals -1. What's my biggest number? 3.5. And that happens at x equals 1. Okay, how are you feeling about that one? A little bit better? Okay, what other numbers did you have trouble with? You guys are totally good on your homework? You're good? Okay, so you guys have 5 minutes. I'm gonna go around and check homework, guys. You can work on your MVT homework. Again, you have 2 days to work on that, but you really should work on it tonight so you can ask questions tomorrow because we're gonna do something different the day after that.